to N0 over EA times X yeah. NL. Yeah, okay. So NLEA dx 0 to L minus 0 to L half dw dx square dx, and this will be N0 and this will be L over EA, right? And minus half half dw dx square dx, okay? And this equal to 0. This equal to 0 because hinge. Okay, so horizontal displacement at 0 and at L, all are 0. So this 0 equal to this, or N0 equal to EA over L 0 to L dw dx square dx. So this is my actual force. Once we got W, there, I got it. So I can determine the EN0. So the actual force can be determined. So this depends on how much Q loading you have, okay? And how much then you have a different value of N0. Yeah. Okay. All right, so we just go back to check my notes, and from here, if I put the W as right, put the dw dx, and this can be written as Q0 over N0 lambda cos x minus hypersine cos hypercosine lambda L over 2. And cos is what? Cos this is equal to lambda L over 2, 1 minus 2x over L. Okay? This is my cos x squared. Okay? And this is a normal, do a variable change. Anyway, so you put this into there and do the integration, you will get the N0. Okay. So you you will get minus right here. You get nonlinear minus 2n0 cubic L lambda cubic over Q0 square EA equal to minus 2/3 lambda L over 2 cubic plus 4 lambda L over 2 minus 5 hypertangent lambda L over 2 plus lambda L over 2 over hypercosine square lambda L over 2. Note, lambda square equal to n0 over EI. So we have a lot of lambda here. Lambda, 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 lambda. So this equation is a highly nonlinear equation of n0. Okay? So for this highly nonlinear, how to solve this n0? You have numerically, right? The best way is a graphic. Okay? For example, if this is f n0 function, the best way is the n0 nonlinear equation. So it's best to graph it. And the 0 point are the solution. Okay? Yeah. So another way where you can use a Newton-Raphson to try a value and convert to the one. But this is a graph method. Graph method. Right? To draw. Okay? You just put the for n0 from 0 to some point. Okay? Yeah. Or you just plot the equation. Okay? And yeah. For example, if you put the equation to, or you can say this is equal to 0 equal to minus to plus. Okay, so this is a nonlinear equation. So I define this as f n0, right? So to solve this function, to draw this f n0, you graph it. Okay, you graph it. Yeah. And for the value equal to 0 is a root. Yeah. Okay, just try a different value of n0 and input into it, and find the value, the n0, to let the function to 0. Another is method we call Newton-Raphson. Yeah, Newton-Raphson methods come from the Taylor series, Taylor's expansion. Okay, we have the fx1 plus delta x equal to 0 and equal to fx1 plus partial f or df dx, right, at x1 times x1 plus delta x. No, this is delta x. Okay, delta x. Right? This is a Taylor series. Just this series means the means like this. Okay. Okay. Delta x is equal to x2 minus x1. So this is x2. Okay. So the value of x2 equal to the f1 value plus the slope. Okay. Then the Newton-Raphson method give me a formula. So the x, okay, 0. Okay. So this is an equation. So my okay. So my delta x is approximate what? The minus fx1 x1 over df dx at x1. Okay, so we can see this way. So if this is a xn and this is a xn plus 1, this xn, this xn. So this is a xn plus 1. So xn plus 1 is equal to minus xn. Okay, so this xn. So from this Taylor relationship, I can have this iterative formula. So my xn plus 1 equal to xn plus minus partial f, the value as xn, divided by the f dx, the slope at xn. So what this? The iterative